1 minute, sir. I'm giving
Yeah.
live. Okay.
Yeah, it's okay.
Govardhan,
Ma'am,
start.
good afternoon and welcome everyone to today's 112th episode of Creative Online Weekend Talk. Myself, Govardhan, your host for this talk. The topic of today's talk on how is earth science important in our daily life. We often to take our planet for granted, but earth science plays a vital role in shaping our understanding of the world and improving our daily experience. This webinar will explore how earth science impacts us in various ways. Join us to discover the hidden connections between earth science and your daily experience. Creative is a group of people who are like-minded and curious to gain new knowledge. Cre means creativity and active means to be activeness. Creative means to be active, we need to be creative. Knowledge Square is our tagline. Sharing of knowledge will increase our knowledge. The vision of Creative is to build constructive thinking on various domains. Our focus is non-textual, non-academic, non-syllabus concepts. Every Saturday, we organize online weekend talks on the Zoom platform and we live stream our program on our YouTube channel, Creative GBD. Creative is thankful to all resource persons for engaging us with their knowledge. We encourage you to actively participate by asking questions and engaging in discussions at the end of the session. To present today's talk, we have Professor R. Shankar, marine geology, retired professor of marine geology, Mangalore University, with us today. Professor R. Shankar retired in August 2017 as a professor of marine geology at Mangalore University after serving the university for 37 years. Had his early education up to BSc in his native place Chitradurga. He is an MSc Applied Geology and PhD from the Indian Institute of Technology, Bombay. He secured first rank in MSc, for which he was awarded the Institute Medal and the Institute National Prize. Professor Shankar was a Commonwealth Academic Staff Fellow at the University of Edinburgh, Scotland up to 1991 and 92. He was conferred the National Mineral Award by the Government of India, Sir C.V. Raman Award by the Government of Karnataka, Young Scientist Award by the Karnataka Association for the Advancement of Science. He has visited 26 countries in all continents save for Antarctica for research, training and Earth Science Olympiad activities. Presently, Professor Shankar is advisor to the International Geoscience Education Organization and member IUGS Commission on Education. He is also coordinator for the International Earth Science Olympiad. He is advisor for Earth Science at Prayoga Institute for Education Research, Bengaluru. In the past, he was national coordinator for Earth Science Olympiad, chair International Earth Science Olympiad, advisory board and examination board, and a member of its syllabus commission. He was a foreign secretary and council member of the Geological Society of India. He published 85 referred research articles. His research articles interests include environmental geology, environmental magnetism, earth science education, and popularization. Thank you for being part of this session and welcome to this session, sir. Over to Supriya, ma'am.
Thank you, Govardhan. Over to you, sir. Shankar, sir. Shankar, sir.
Yes, I'm here.
Yes, sir. Okay.
Can you hear me?
Yes, sir. Yes, sir.
Okay.
You can take over.
Okay. A very good afternoon to all of you, my dear students, ladies and gentlemen. Thank you so much, Mr. Govardhan, for your kind words of introduction. And I wish to, at the outset, thank CREACTIVE and particularly Dr. Supriya for the gracious invitation for today's talk. Thank you so very much. And it gives me great pleasure to talk to students and to common people all about earth sciences. Well, it's a very interesting and fascinating science subject, but unfortunately, many people do not know about this. And this is what prompted me to give this talk today through CREACTIVE. Can you see my screen?
Yes, sir.
Okay. Yeah. My talk today is.
It's in normal mode, sir. Now it's presentation.
Okay.
Thank you.
So the title of my presentation today is How is this is the framework of my presentation. I'll first give an introduction and then speak about all of those aspects of earth sciences, and then finally give some concluding remarks. Well, due to peer pressure and parental pressure, our students at the peer level choose, very few subjects for their higher studies and careers. But I would like to emphasize, friends, that it is not just medicine, not just engineering, not just biotechnology that are important and are available to all of you. There are other equally interesting or perhaps more fascinating and more absorbing fields also besides these. For example, earth sciences. Earth science is something that is all pervasive. It encompasses all aspects of our lives, as we will discover in a few moments from now. Now, what is earth science? Earth science is the study of not only the solid earth, but also a study of the atmosphere, the hydrosphere, the biosphere, the cryosphere. Cryosphere is that sphere comprising of glaciers, ice sheets, ice caps, everything that is frozen water. And then it also includes planetary geology. Now let's look at various aspects of earth science and how it is helping us and how it is important in our regular day-to-day activities and lives. First of all, we obtain many types of resources from Mother Earth. For instance, the water that we drink, water that sustains our lives, both at the surface and subsurface, it is from the Mother Earth. And the food that we grow, we use soil or water for this purpose. So without soil, we cannot grow much. Then we need metals, we need non-metals for manufacturing various things. They're all obtained from Earth through ore materials and other minerals that are explored for, and we mine them and extract the metals. Then we use it for various purposes, as you can see here in the top right slide, and many others. And as civilization improves, we consume more and more energy. We need more electricity, more power for our engines, for our factories, industries, and so on and so forth. Where do we get this energy from? We get it from things like coal, petroleum, natural gas, and also there is something called gas hydrate. This is a relatively new mineral deposit. Then we also have nuclear minerals like uranium and thorium. And I would like to express my view, which is a fact, that all of these earth materials are non-renewable resources. When I say non-renewable, once we mine and use them up, they're gone forever. And if a new deposit has to form, it takes millions of years. I repeat, millions of years. Whereas if you take food resources like food crops, vegetables, fruits, you can grow them every season, every year. Not so with mineral deposits. So we need to exercise caution in using these resources. So my urge to all of you is to conserve these resources. I don't mean you must be miserly. Do use them, but do not misuse any resource for that matter. It can be water, it can be electricity, it can be food, anything. Just do not waste anything. Then we also can harness not renewable resources of energy. For example, we have hydroelectric power from river station, river projects, wave energy and tidal energy from the oceans, solar energy. In fact, countries like India that are located in the tropics receive so much solar energy that it is criminal not to make use of it. But only in the recent times, we have realized this importance, and India has been in the forefront to put forth the International Solar Alliance. And also very recently at the G20 meeting, we had the biomass convention or alliance, something like that. Then we have biomass energy, geothermal energy. Geothermal energy is the energy that we obtain from Earth, where there is high heat flow. For example, in some Himalayan regions, there is so much heat that you can actually send water down. It gets quite hot, and then you bring it up and make steam out of it, and you generate electricity. Then, of course, we have wind energy. India also is blessed with good wind speeds at different times of the year, most part of India. Then we need construction materials to build buildings, roads, everything. The bricks, the jelly or the road metal, sand. And then we are also fond of gems and precious stones. Not me, but some others are very fond of these. These are all obtained from planet Earth. And then we have many types of hazards, both natural as well as human-induced, like floods, droughts, earthquakes, etc., etc. The point here is, it is very important to predict these hazards and to prevent and mitigate them as much as possible. Earth science knowledge is very important in this aspect because all of these are linked to the processes that take place inside the Earth, also on the surface of the Earth. For instance, earthquakes, they damage buildings, people lose their lives. And it's important to know where, when, and what magnitude of earthquake will take place. We need earth science for that. There are floods, landslides, there are volcanic eruptions. All these hazards. And then we have snow avalanche, dust storms, cyclones, forest fires. All of these are creating havoc, particularly in the recent times. I'll not go on giving examples because you're aware of these both from India as well as from other parts of the world. Then there is this problem of coastal erosion in coastal areas. I lived in Mangalore for 37 years, and I've seen this happening every year. Then we have tsunamis. Please notice the height of the tsunami wave and compare it with the buildings here. See, these are huge masses of water, maybe about 60 meters high sometimes, and moving at great speeds of an aircraft, which is about 850 kilometers per hour. That's the speed at which this huge wall of water comes and hits the coast. Probably must have seen some videos of tsunamis. They're available on the internet. Then there is the aspect of climate change, a little bit of it later on, which is creating havoc in our lives. So earth resources and earth processes together impact our environment, they impact our economy, they impact our health. And they're also important in terms of our security, in terms of our safety and sustainability of life on planet Earth. And then, we construct, several buildings. These are mega engineering geological projects, mega engineering projects. Again, some examples are dams, nuclear power plants, reservoirs, foundation for projects, high-rise buildings, tunnels, highways, railway lines, metro lines, runways. All these are mega engineering projects. In the context of these projects, it is important to locate, to design, to construct, operate, and maintain them properly. And that's where earth science comes into the picture. Let's see with a few examples. We certainly do not want to construct a dam in an unstable region, in a region which has possibility of earthquakes. Because if you build a dam there, when there's an earthquake, your dam is gone. And this is what happened in Libya, right? Because there was no earthquake, but the two dams burst there and thousands of people died and several tens of thousands more were displaced or they're missing. Then you have reservoirs for various purposes. We do not want to have a reservoir in an area where there are lots of fissures and cracks inside the earth below the surface through which water can percolate. So if that happens, your reservoir water will be lost unnecessarily. So you want to choose an area which contains very little or no fissures and cracks. And if you want to build railway lines, you want to align them properly. Again, you can see here what an earthquake has done to the railway line. Of course, this is not to mean that we should not run railway lines in areas that are earthquake prone, but we have got to take precautionary measures. Then we make tunnels. If you go to coastal area, there is a Konkan Express. So there are several tunnels through which Konkan Express passes. In all of these tunnels, it's important that there is no caving in of rocks from above, as you can see here in the bottom right photo. And we can ensure that by studying the structure of the rocks, at what angle and in what direction the rocks are sloping, things like that. And then properly align the tunnel with respect to these geological parameters, and then your tunnel is safe. You will not have caving in problems. Then you build highways, how to align. You need earth science knowledge. You need runways, you need to build them. And these aircrafts, when they land, there is so much impact on the runway that it has got to be very, very strong. So you need materials, rocks that can withstand this stress. When you want to build sky-rise buildings, skyscrapers, you need to have proper foundation. You need to build in an area where there is no subsidence, right? So you need earth science there. Once again, when you want to build a power plant, like the one in Kaiga near Karwar, so you want to put it up in a place which is stable. There is the least chance of an earthquake happening there. Then there is something called urban geology, land use and land use changes. Basically, in urban geology, what we do is we study the area, we study the geology, we study the soil, we measure the properties of the soil, and then suggest what should be built and what should not be built. For example, in this map, you can see low density residential area That's wetland in green color, commercial office space, high density residential, medium density residential, and so on. And this is a marshy area. So it's very important that we plan our cities properly, which is very important. So we need to plan our urban areas really well. We should take care of the water bodies because these water bodies are the main supply sources of water in many cities. Bombay, for example, has several lakes, Powai Lake, Waitanda Lake, etc., which supply drinking water to the city. And we need to protect these water bodies, and they need to be desilted. In fact, in the olden times, the kings were very particular that the water bodies, tanks were regularly, annually desilted. And the silt taken out was used for agriculture, which is a fantastic manure. So you get manure free. And secondly, when you desilt, you're increasing the bearing capacity of the water body. So all the water that comes during the rain will accumulate in the water body, it doesn't flood. But today, what's happening? In Bangalore, for example, we have done constructions on Rajakaluways, stormwater drains, and very recently, all this has created a havoc. Crorepattis or millionaires had to travel on a tractor or in a bullock-drawn cart. Such was the havoc and problems created, all because of lack of proper planning in Bangalore. Then there are climate change issues. But what is climate change? Climate has been changing for millions of years. There's nothing new about it. But we restrict the term climate change for only that part of climate change that is induced because of human activities. It's mainly after 1850, when the Industrial Revolution began, that large amounts of coal, petroleum, and natural gas were used, were combusted, and we gave up a lot of carbon dioxide to the atmosphere. So atmospheric carbon dioxide concentration went up, and that caused the greenhouse effect. Carbon dioxide, methane, water vapor, and several other gases are all greenhouse gases. They increase the temperature of the earth. So that produced global warming. But today, it's no longer global warming, it is global boiling. Very nicely put by the UN Secretary General, Antonio Guterres. As a result, we also have sea level rise and the submergence of coastal areas and submergence of small island nations. And it's going to happen in the coming decades. So what we need to do is we need to obtain data on the past climate. That is, we have two branches in earth science called paleo. Paleo means past. Paleoclimatology and the past oceanography. How the climate was in the past, how the oceans were in the past. Add to this the present meteorological data, the weather conditions. Combining these two, we can model the data. And with that, it is possible to predict the future climate scenario. Of course, there is always plus and minus. There's a little bit of uncertainty, depending on what type of a model you choose. But still, it is still possible to predict in a very general way in what direction climate is going to change in the future. How to slow down climate change? That will be a topic for another webinar. So I'll not say here much more than saying two things. One is we must conserve resources. As long as we continue to waste resources, misuse them, abuse them, we are not going to arrest climate change. It has already begun. We can only slow it down. It's still possible. And then we have a very interesting field of earth science called medical geology. It's a sangam of medicine, geology, and geography. Basically, medical geology deals with the health effects of geological materials and earth processes, both on humans as well as animals. The health effects can be good, it can also be hazardous. So there are some things that can do good to you, others may harm you. So there is a need for geologists and medical people and public health experts to come together and do this research in a multidisciplinary way. I'd like to quote Hippocrates, who said, if you want to learn about the health of a population, if you want to learn about the health of a population, look at the air they breathe, look at the water they drink, and the places where they live. So beautifully said, right? So in a sense, too much or too little of micronutrients or minerals is harmful. And this can lead to health problems. For example, arsenic and fluorine in groundwater. This is arsenic problem is particularly prevalent in West Bengal. Then fluorine in groundwater, you get fluorosis, which is there in Chitradurga, Davangere areas, and many other places in the country. Depends on how much fluorine is there in our water. Then a similar thing is also true for crops, which takes us to another field called agrogeology. So basically, we look at what is present in the soil. Is it deficient in certain nutrients that the plants need? And if so, you need to supplement your soil with appropriate fertilizer, not simply dumping NPK everywhere, irrespective of whether it needs or not. Recently, one of my friends showed me an app through which you pay some 500 rupees for about 7-8 acres for 1 year, and you can get data through satellite on what is the water content, soil moisture content, and what is the topography, what is, if there is any disease, you can notice through the chlorophyll content, and several other parameters can be obtained through such apps using satellite data. Then there is a very, very interesting field called forensic geology. As you may have guessed it, this is making use of earth science to help in crime investigations. A very early forensic geology case was actually in Sherlock Holmes' novel. Here the case was solved by comparing the soil that was stuck on the suspect's pants. That was compared with the mineral content, which is actually mica, in mud from the crime scene. So you match the mud from the pants with the mud from the crime scene, and you match. If it matches, then he or she is the suspect. So that is just to demonstrate what was done in this novel. And when Ms. Supriya called me a few days back, I was actually watching this English movie, Knives Out. It's such a coincidence. In this movie also, there is the detective says, look at the soil that is there on the carpet. He tells his assistant to collect sample of the soil and match it with another place where crime took place. So this is just one instance as to how earth science knowledge can aid crime investigations. So it's not only DNA fingerprinting, but also geology can help in crime investigations, in nailing the culprit. Then we have pollution of the environment. We have various types of pollution. We have air pollution, we have water pollution, we have sound pollution, soil pollution, radioactive pollution, and whatnot. And it is necessary that in order to know where these pollutants are moving, how they are moving, what direction, at what speed, and how to combat this problem. It is the Earth's magnetic field which helps in navigation. the compass needle that many of you use in your labs, in physics experiments, they'll not work if there was no magnetic field in the earth. Then take the oceans, another part of the earth. We have masses of water moving. You can see in this map, the water mass moves from one place to another sometimes in a curved manner, straight line. All these are surface currents, but there are currents inside the ocean as well. So there is a mass of water moving, we call it an ocean current. Current is current, right? It can be air current, it can be electric current, it can be ocean current. So ocean currents are important because we can make use of, take advantage of the currents when we do shipping. So that way you can save fuel. And oceans are also important in terms of trade because we use them for bulk transportation of goods. Fishing is possible, recreation. You go to the beaches and enjoy yourselves, engage in water sports and so on. Notice this here, it's the same area, 2 photographs. The water level is down here, it's increased here. How come? Because of tides. The periodic up and down movement of sea level because of the gravitational attraction of the sun and moon on the earth. It's important in harbors because there are ships, huge ships, they cannot enter the harbor at low tides. At low tides, it will get grounded. It needs to wait until you have high tide. Then atmosphere is also important because it provides us, it acts as a shield. For example, the ozone layer that is there, it protects us from ultraviolet radiation. What if there is no ozone? The ultraviolet radiation reaches the Earth's surface and will have skin cancer and all types of other problems. And atmosphere also is important in terms of magnetosphere. Because this magnetosphere prevents most particles from the sun that are carried by solar wind from hitting the earth. Then there is another field of study called planetary geology. This is very interesting, particularly in the context of Chandrayaan-3. So let's see what this is. Now, there has been space exploration. There has been a spurt in space exploration since the Cold War began between the US and the USSR. And this also spurred the quest for new abode, new place, or new habitat for humans outside of planet Earth. Quest for new mineral resources. We are not content with what we have on planet Earth. We want more and more resources. And the quest for supremacy in space exploration. If you go back to the 90s, in all of this, Earth science knowledge is very important to understand the processes that happen in other planets. Because unless we know the processes here on the Earth, you cannot study other things on other planets. So, in planetary geology, we get questions like the Earth processes that take place here on planet Earth, do they also take place in other planets? Are other planets fit for human inhabitation? And is life sustainable on those other planets? For example, the moon or the Mars. So these are questions that can be answered only with Earth science knowledge. Then it's also important in terms of resources. For example, we know that asteroids contain rare earth elements. They contain platinum group elements like gold, platinum, and other elements. And moon is supposed to be important in terms of helium, which is an isotope of hydrogen, and that is important in terms of energy. Lots of energy can be obtained from helium. So that's why people say that India and many other countries are in the race to go to the moon and to extract this. We do not know when this will happen, but all these are possibilities. From the way things have happened so far, it's often difficult to predict what will happen in the future. So, ladies and gentlemen, you've seen how earth science knowledge is helpful to us, how earth science impacts our lives in several different diverse ways. So in conclusion, I would like to say that we need earth science in all walks of life. There is no fun, there is no life, no comforts without earth resources and earth science. It is earth science, earth science, earth science all the way. I just would like to show a couple of slides more just to help our high school students. This is the website of the International Geoscience Education Organization. That's the website address, igeoscied.org. It contains important teaching resources with regard to Earth. You can click on this and look at various resources that are available for teaching, learning Earth science. Some are very interesting. And here, in this organization and the International Earth Science Olympiad that we organize, the emphasis is on Earth system science. The emphasis is on planet Earth is one system, which is comprised of several subsystems, as I mentioned in the very beginning. The philosophy here is the same as what our ancient scriptures said, Vasudhaiva Kutumbakam, means the earth is but one family. Also, there is another important thing here. There's a geoscience textbook by the name Exploring Geoscience Across the Globe. This contains very elementary earth science topics that every student should learn in order to become an earth science literate and responsible citizen of the world. Look, and it's very nice. Then we have another website called www.earthlearningidea.com. Here, we have published hundreds of practical demonstrations wherein we make use of easily available, inexpensive, cheap materials. You don't have to buy anything. What's around you can be used. And you can demonstrate many earth processes like earthquakes, volcanoes, erosion, mountain building, how the Himalayas came up, all things like that. So all that is in Earth Learning Idea. So friends, thank you so much for, there's a spelling mistake here. Thanks for your time and attention. After the session is over, in case you want to be in touch with me, you have my email address and also my mobile number. Welcome to. What technique is used to know the quality of underground water? One second. Okay. What technique is used to know the quality of underground water? It depends on what you want to test. If you want to, determine trace element concentrations or ions, Then there are methods like atomic absorption spectrophotometry. And there are also simple methods by using electrodes, you can find out the anions and cations that are present. Then there's another question. Please tell us about tidal energy stations in India. In India, we have a demonstration plant, tidal energy plant at Vizhinjam in Kerala. This was set up by the NIOT, National Institute of Ocean Technology. That's located in Chennai, of course. There's also a very potential area, the Gulf of Canberra, Gulf of Khambhat, where there's a huge tidal potential, tidal range. For crops, for making borewells, I didn't understand the question. There is no question here. It is from Bharti Kaushik. Can you please specify the question?
If anybody wants to ask questions, you can raise your hand so that I can unmute you. Bharti Kaushik, you can directly ask your question.
I would encourage the students, particularly the youngsters, to ask questions. So it's important to ask questions. It is important to ask questions. Why, how, not so much as what. Why is important? Only then, we can make progress. Okay, there's a question here. Why still earthquakes are not predictable? Fantastic question. See, the problem here is in the case of earthquake prediction, we are able to predict earthquakes, but many times, they don't come true because we need to get three things correct. Firstly, when will it happen? Where will it happen? And what will be the magnitude of the earthquake? If any one is not correct, then your whole exercise is waste. For example, I say that, Bangalore is going to have an earthquake about 10 days from now. Okay. And I say it is a small earthquake, not a very big magnitude earthquake. And if it happens in Bangalore, if it happens in 10 days time, right? And if it is a big earthquake, then it's a disaster. Whereas if I say the opposite, it's going to be a big earthquake, but a very small tremor takes place, then, unnecessarily, you're alarming people. You get the point? I can say the same thing if the place of a prediction is going to be different. So that's why it's difficult to predict earthquakes with respect to all the three parameters. All right.
Okay.
Any other question?
Jyoti ma'am texted again. So.
Okay. What is the impact of plastic waste on Earth? Plastic. This is mainly on animals. You must have seen, a cattle, eating plastic, and a lot of plastic is found in the tummy of a buffalo or a cow. This is what we can see. But what is not seen is the plastic that goes into the oceans, that goes into animals, stomachs, and also animals getting stuck, with the plastic covers or plastic paper, plastic sheet, for example. Not only plastic, there is also the concept of microplastic today, which many people are not aware of. See, we are very fond of drinking bottled water. thinking that mineral water is good. But unfortunately, when we store water in plastic bottles, the plastic enters the water very slowly but surely. And that is what we call microplastic. And this impacts on our health, human health, health of animals. So those are the things that happen because of plastic pollution. Then recently a scientist discovered a fungi which can decompose plastic. Is it true? Not an expert on this, but I don't think that has happened. But I'm not very sure. I don't think so. Any other question?
Sir, one more question in chat box.
Okay.
What may be the result of too much mining?
What may be the result of too much mining? Too much pollution. Simple. We must remember that, if you want to extract 1 ton of iron, several thousands of tons of iron ore has been mined. All that means dust pollution and pollution of the river environment, pollution of air, pollution of water. And all this is impacting on our health. Yeah.
Any more
Samarth,
questions?
any question? Samarth, any question? Okay, what causes plate tectonics always moving and unstable? What causes plate tectonics? It is the heating inside the earth that produces, heat. There is convection. Convection, right? You heat up here, it comes up and then it cools and comes down here. So you have a convection cycle. The same thing happens inside the earth. Because of this convection, the plates move on the surface of what we call asthenosphere. Did I answer your question?
ಲೋಕೇಶ್ ಸರ್ ಏನಾದ್ರು ಮಕ್ಕಳ ಕ್ವಶನ್ ಕೇಳೋದಿದ್ಯಾ?
There's another question. Are tsunamis predictable? Yes. See, basically, tsunamis are produced when there is an earthquake of a strong magnitude, a strong earthquake, high magnitude earthquake. So when an earthquake takes place, this is picked up by seismographs. These are seismometers. These are instruments that can detect earthquakes. So we have a system of these seismometers in the world. So as soon as an earthquake is detected, earth scientists make calculations to find out what is the magnitude of this earthquake. And if it is a high magnitude earthquake, then there will be an alert sent through radio, through social media and whatnot. Announcements are made that there is a possibility of a tsunami coming up. And then you see people can take precautions, move away from coastal areas. They should essentially move up to higher elevations, run away from the coast, or go to or climb a tree, go to a higher elevation, or maybe a building, right? So those are the precautions that one can take if there is a tsunami. I must mention in this context that India has set up a network of pressure sensors which can sense the earthquake waves that pass through the water, and they make an impact on the pressure sensors. And then you see we get a signal that earthquake is possible, and it involves calculations and making an announcement. So here again, Indian Ocean is having a system set up by India, by the erstwhile Department of Ocean Development, and is helping the Indian Ocean bordering countries. Earlier on, it was available only for the Pacific, but now India has set it up in the Indian Ocean as well. The next question is, do volcanic eruptions add pollution to Earth? It's a very interesting question, yes. What is the definition of pollution? Can anyone give the answer? Basically, we define pollution as an excessive concentration of an element caused by human activities. Okay. Whereas if it is done by natural processes, it is not considered pollution. This also reminds me of a saying in Kannada, "Atte hodada madakege bele illa." It means a pot broken by mother-in-law is pardoned. But the same thing if done by daughter-in-law, it is an offense. So something like that. So if we do all these things and we increase the concentration of an element in the atmosphere or water or soil, that is pollution. Whereas natural processes giving out a lot of high concentration of elements, that is not considered pollution at all. I'll take the example of hot water springs on the ocean floor. You get water in thermal springs, hot water springs at temperatures of 300, 380 degrees centigrade. And they contain quite a bit of base metal elements like iron, manganese, copper, nickel, cobalt, and rare earth elements. That is quite toxic, but that is not pollution, right? And then the next question, forest fire. The next question is, addition of unwanted particles to Earth. By whom? That is the point. If we add, its pollution. Nature does. That is a natural process. It's not considered as pollution. Forest fire is also natural by lightning. Forest fire is natural, yes. It can also be because of human causes. See, the incidence, the frequency of forest fires has increased. And that's because we have changed the climate because of our human activities. So I would say forest fires are because of natural as well as anthropogenic or human-centric causes. And the next question is, what a pyroclastic material which is involved in volcanism? Pyroclastic, I have to remember what I learned in MSc many decades ago. Honestly, I do not want to give a not so very good answer. I can Google and check up and let you know. 1 second, please. Okay, pyroclastics are a type of volcanic clastic deposit. It's basically a deposit formed by volcanic ash material, particles of volcanic products. So that's what it means. I don't know whether I answered your question. Is it clear to you? Harapriya Jina. Okay. Yes.
I'm giving access to unmute yourself and ask the question and interact with Shankar sir.
Yes, that would be nice. Yeah.
Yes, sir. Yes, sir. Okay. You unmute, sir. Okay. If any questions, you can directly ask by unmuting your audio. Girish, sir, any questions, queries? Vasishtha, sir. Okay. Girish, sir, go ahead.
Thank you, Supriya. Thank you, Supriya. I do not have any questions. Okay, I am very happy and I am thankful to Shankar sir for the wonderful talk.
Pleasure. Who is this? Who spoke
Girish.
just now? Okay. Thank you so much, sir.
Hello, namaste, sir.
Namaste.
Sir, will you please tell me the job opportunities who will study the earth science subject course?
Okay. I knew that you'll ask me this question, so I have some slides kept at the very end. Okay. So job opportunities, careers in earth science are possible. See, one can become a professional like a geologist or a hydrogeologist. Hydrogeologist means you're basically looking at and all that stuff. Can become a geophysicist. This is a guy who does exploration. Geochemist, he looks at the chemical elements in earth materials, in rocks, soils, water. Mining geologist, somebody who helps in mining, the ores. Petroleum geologist, coal geologist, these are quite easy to understand, right? And nuclear geologist, and there are many other professionals in earth sciences. Then there is also the possibility of choosing teaching and or research careers. And this is possible in universities, both public and private. And this is also possible in colleges and schools. It depends on your interest. Then
Thank
there
you,
are, no, I'm not done. There are also research only laboratories. And one can also become a consultant. One's own boss can be doing the work of consultant. Then there are several earth science institutes and organizations. I will not read all of them, but only pause for a while so that people can look at it later and make a note of those. Then there are private companies. And there are teaching and or research, several universities, IITs, ISM or the Indian School of Mines, colleges, schools. I didn't include the ISERs. Then research only, we have the National Institute of Oceanography, National Center for Polar and Ocean Research, National Geophysical Research Institute, Physical Research Laboratory, and privately as a consultant. So those are the things that I had in my mind because I knew you will have a question on this. Okay.
Thank you once again.
Any other question or comment?
Hello.
Yes, please.
Yes, sir, just vehement thanks and compliment for a very, very insightful presentation. Some of the question which I was carrying to ask in a Q&A session has already been covered in your presentation. So now at the concluding end, may I request you if you can share the PPT as a PDF for the same, for sharing with the larger groups for the benefit of the people in general.
Certainly. I'll do that.
I'm calling from Hindustan Zinc. I'm general manager and head exploration tour.
Okay.
Yeah.
So nice of you.
Thank you, sir.
To...
It was really joy. It was really a joy listening to you after a long time, sir.
Have we met Dr. Vasisht?
Yeah, I think so because I'm also retired one, recently retired.
Where did we meet?
Possibly somewhere, I think in Karnataka somewhere I'm feeling. Either in Bangalore, Chitradurga or Mysuru. Because I used to be a frequent speaker from Vedanta Hindustan Zinc side on exploration.
I see. Okay.
Thank you, sir. Because
Thank
one
you.
of our senior is there, Mr. V.L. Upadhyay.
Okay. That's
So
nice. Thank you
really,
so much for your kind words.
thank you, sir.
And we should take our science to common people, to students, so that
Absolutely right,
they,
sir.
they
Absolutely
will become
rightly worded.
aware. Yeah.
Yeah.
So you go to high schools, there is physics, chemistry, mathematics, biology, there's also computer science, but there is no earth science. How will
Sir, in Rajasthan, we have initiated, if required, we will share the details. With our constant persuasion for last 10 years, now this geology has been entered into school education.
What level?
+1 and +2.
Okay. Plus
10
two.
+1 and 10 +2.
Okay.
We, as a collective people, collective forum, prepared textbook in regional language like Hindi and English.
Yes.
And our effort of last 10+ year is now fructifying into government notification of expanding earth science colleges curriculum in many colleges in
Very nice.
remote area as well as in +2 level school education. So I think it will be percolating at the early stage before they come to the college with some prepared mindset to opt this career.
Okay.
So if required, we can share also. If it can be of use to other state, pan India, because our concern, like all of us here, is a common concern that it should benefit should be an pan India level.
True. Odisha also has done the same thing as you mentioned in Rajasthan. Odisha also has geology in +2.
Yes, sir. And we are expecting that coming 5-10 years, it will be covered in the majority of the schooling. It will be a regular part of the something like physics, chemistry, mathematics, and biology sort of thing.
Yeah.
Because it's having a tremendous impact on this career option also.
Yes. Yeah.
So at the right time, if people with right mindset enters, then they have a sufficient incubation period.
Yes.
Yes.
This is my email address and phone number. If you can share yours, it'll be nice. Just send a
Sure, sir.
Message to
If
me.
possible, just put PPT or PDF on same Intech GeoHeritage WhatsApp group also, sir. It will be largely benefiting many people.
I'll send it to the host. I'll send it to the
Right,
host,
sir.
Miss Supriya, and she'll
Right,
distribute
sir.
it to all the people, right?
I think
So
that will be great one.
What I'll do, I will make a PDF file. PDF file.
Right, sir. Right, sir.
Yeah.
It will be limiting the size also without compromising the intended takeaway.
Yes.
Right.
Any other questions?
My thanks to host also for very efficiently conducting the session. Very crisp, very timely. It was true joy and knowledge sharing.
Thank you so much.
Thank you.
Thank you, sir. Okay. Any other questions? We are running out of time. Shall we conclude, sir?
Sure. You're the boss.
Okay. We are at the end of the session. We are very thankful to Shankar sir for sharing your insight knowledge with us. And it was very pleasant presentation. I think everybody enjoyed today's session. And I thank all the participants for joining with us actively and asking questions and queries. So we are very thankful, one and all. We are ending this session. Thank you, Shankar sir.
Thank you so much.
Okay.
It was a great pleasure
Thank you.
talking to all of you. I hope it has